It's an ebook. It's called How to Become a Freelance Data Scientist. And basically, it's free if you join my email list. So I can, it's not open. Yeah.
That was the trick.
That's the trick.
Yeah.
That's the trick.
Your email list was.
Yeah, that's me.
I'm
gonna paste it here on the channel.
Here it is. Do you have the articles available in your website?
Okay. Yes.
No,
I mean, I just pasted basically the link where if you subscribe, you get it in your first email.
Nice.
For free. It's free.
You have started with the Substack, huh?
Yeah.
Nice.
You're not cool if you don't use Substack. That's what I realized. I used to use MailChimp, and then it was not doing the job for me.
The latest trend. Everyone in the Substack. Okay, so let's start.
Yeah.
Yes, this is gonna be recorded, so people later can watch it, and I will probably put it on the YouTube. So, introductions. Welcome to this webinar interactively. You can make any question that you want. I have left a link in the chat. I don't know if you can see it. It's for Slido. So if you go to this link, you can type any question here. I will gather the feedback to later reply. I will ask the questions to Pau. So, Pau, what has brought you here? What is your scope of influence in Twitter, LinkedIn? What are you trying to build?
What brought me here, Jesus, is not data science, but my wife. Because I used to work in a bank. I used to do boring stuff, and that was
which bank?
That was in Austria, in Europe. It's called Erste Bank. It's one of these classical big European banks, like a safe environment. So, I started working there, but that was 10 years ago. After 3 years, I got really tired. I got really depressed, among other things, because I was not happy living the way I was living. And then is when I heard about data science, because nowadays data science, you hear it everywhere all the time. But 10 years ago, it was it was a new thing, really. It was not, it was really uncommon, but it sounded attractive. So I said, why not? I'm not a data scientist. I'm not a data science expert because I never studied that. But when I checked job descriptions, it really looked like something I could learn, something I would love working on, learning. And now it got to the point that I realized that I enjoy even more if I teach others and if I help others learn it. So this is what brought me here. This is the whole arc of trying to get where we are now.
Within the bank, which type of software you used? If you use some software at all about data or something?
No, it was just pencil and paper.
Okay.
No, I'm joking. No, still, banks are they're still quite traditional, at least in Europe. So data scientists essentially use one thing, which is Excel and MATLAB. Because
MATLAB. Wow.
Yeah, it's one of the things that I learned in a bank and I never used again, right? MATLAB. It's a proprietary kind of software platform. It's really expensive. It's really slow, but somehow it got traction 15 years ago. And banks are very rigid when it comes to technologies. Open source is something you will never hear in a bank because of compliance, because of security, because of so many things. So those institutions stick to very conservative technologies and ways of working. So so every time I see a bank saying they hire data scientists, I'm really, really skeptical. So, but yeah.
Let's see which type of technology they're using, because in some conversations also I heard that some banks still use COBOL, which is a programming language from, I don't know, the 60s. I think COBOL. Have you heard about it?
Yes, I've heard it. And I think my dad actually studied a bit. So
Yeah. So after you
yeah.
finished, you decided to move into the data science. Which were your first step?
Well, my first step was to try to study data science, right? Because nowadays there are lots of programs, lots of online courses, but 8 years ago, there were not many. There was this pioneer, Andrew NG. Nowadays, he's really well known. He published one of the first courses about machine learning, and he put it on Coursera. And that was the course that I took, right? So this is a course that takes you from the fundamentals, which is linear regressions, logistic regressions, and then you enter into random forests. So basically, it covers from let's say simpler to more complex machine learning models, and then it ends up doing a little bit of neural networks. So that was the course that I was taking after work for 6 months. And then I was reading blogs here and there, right? Because one of the things that you realize as soon as you start studying data science is that there is no one source of truth or one place where you find it all. It's like a conundrum of and a constant discussion of you need statistics, and then you need Python, and then you need neural networks, and then you need boosting methods, and then you need SQL. So somehow, in a rather chaotic way, I tried to find my path, right? So
by trial and error, I guess, right?
Yeah. So looking in retrospective, as any learning path, when you look backwards, it's like cheating, right? You only see the mistakes, and it seems very stupid what you did, but one of the things that I try to keep in mind, and I think it's applicable today, is what's your end goal, right? If your end goal is to find a job, go read job descriptions, right? Try to and talk to people who actually do the job, because what happens nowadays is that job descriptions contain everything, even the things that you don't need at all, right? So it's a little bit misleading. But anyway, keeping the end goal in mind is the only way to somehow navigate this chaotic path in a less chaotic way.
Totally. I remember a friend of mine who told me about he wanted to get into marketing or programming, and he wanted to do web design. And we had a meeting and we discussed, but what's your end goal? So his end goal was to work in remote, you know. And I asked him, in which field do you have more possibilities to work in remote nowadays? So we saw many descriptions in LinkedIn, and the one that was more affluent, which one was? Data science, Python, etc. So yeah, your point is very good, because many people believe that they need to start in a master's, or they need to start by taking courses. But if your end goal is to get a job, then you should go to look the description for the jobs, so that you know which courses you should take, right? Because some people take courses that are not that useful, I guess. Did you have these experiences that you took courses that wasn't up for your job?
Well, absolutely. And starting from university, but I would like to make a distinction. There is, I think, the role of universities and masters in general should be to teach you how to learn, right? It's not about learning specific things. It's not about becoming an expert in certain technologies, because these things move, these things change, right? For example, Apache Spark used to be something that every job description used to have 5 years ago. Now it's still in the market, but I mean, I see it so rarely. So it's not about really overfitting on one technology, but it's about learning to learn, right? Finding your system. And this is what I think master programs should focus on and should offer. Because this is, let's say, the long-lasting skill in this game, right? In data science, it feels like lots of things are changing, right? So it's hard to make a curriculum that fits that profile. And that's true if you try to teach the technologies that people will need in 10 years, because no master studies is going to teach you today the tools you will need in 10 years. And if they tell you, they're lying. Even Python. Python is not going to stay the language of data science ad infinitum, right? Because it's slow. It's just convenient because there are so many libraries out there but it's probably, it just got traction and we ended up in Python, but it's just a network effect. If some people start to invest more in Julia, for example, if Google starts investing in Julia, if Meta starts publishing, things will change. So what I'm trying to say is that the tools are going to change for sure. What is not going to change is your capacity to adapt and your capacity to basically translate business problems into numeric data problems, right? So something that business people talk about, you're able to translate it into something that an engineer can implement in a computer and can, for example, teach a machine to find patterns to solve, right? Machine learning is mostly about finding patterns. And these kind of meta skills are the things that are constant, and other things that are not technology dependent. Another thing that I think you should learn, because it's not trivial. It sounds like easy, but this, I'm learning every day. It's not you get there and that's it, right? But these are I think this is the way to stay actual in this game.
Yeah. Did you start learning with Python?
Well, the thing is that as I told you, I was coding in MATLAB for 3 years, and that really fucked up my mind because during university, at that time, people were studying with C and C++. So I was used to that kind of masochism of trying to write C++. And then I forgot it and I said, never again. I don't want to code, never again. And then I found my first job, and then I realized that I needed again to code, and MATLAB was the name of the beast. So then I started learning MATLAB. But then I heard that MATLAB is not cool. In data science, no one uses MATLAB. Then it's Python. And then is when I started studying Python when I got my first job. So basically, to get my first job, I had to make a take-home project, and I implemented in R. So, it was a complete mess, essentially. So
at least how you just start, right? Because I don't know, for me, in my case, I started learning data science with R when I had to make the transition into Python, and people were calling me to do projects for them in Python. I was a bit reluctant because I was thinking to myself, I already dominate R. Why bothering learning Python? I am so comfortable with R. In your case, was it the same, or you were open to new challenges, let's say?
No, I was really happy to learn Python because I realized that people still use R, but much less than Python. So when I got my first job, in the first weeks, I was basically going through projects that were already implemented in the company. It was a mobile gaming company, so there were several machine learning models to do these typical things.
Which mobile company?
It's called Nordeus.
Maybe you can control the screen.
Yeah. Wow.
You click. Nordeus.com.
Yeah.
So this
they have this soccer simulation game, Top 11.
Top 11. Wow. And they implemented machine learning in this software, right? Yeah,
they implemented machine learning to do, for example, in-game recommendations. So this is like a soccer simulation game. So you as a player are in charge of managing a team. So you tackle transfers, you organize the tactics for the upcoming match. So you're the manager. You are Joseph Mourinho, right? So and one of the features inside the game is constantly recommending what's the next player you can acquire, right? And one of the things that they solved with machine learning was, what player should we offer you so that you buy it, right? What's the thing that you need as a manager?
Which was the first machine learning model you developed in this game?
The first that I developed was not an in-game model, but it was used for marketing purposes. So it was an LTV prediction. So LTV stands for lifetime value. So when you acquire a user, when you basically spend money on Facebook ads to bring a user, the first thing you want to understand is how profitable that user will be. So you have two options. You can wait 3 months and see what happens, but this is not the best. Or you can today use a predictive model that, using all the data you collected so far, gives you a good estimate of how much revenue that player is going to give you in the upcoming, let's say, 6 months or 1 year, right?
Wow.
Because with that number, the marketing team can almost real time understand the profitability of each campaign, right? So they can basically adjust on a daily basis budgets and say, okay, this campaign is bringing low quality traffic, low quality, let's say, low volume of revenue, so we should stop. So it's a way to spend marketing budget more efficiently. Let's say.
Absolutely. Wow. And within the job, before you got in this company, did you feel prepared to tackle the task that they put in the job offer? Because
No.
I see many people that they go through job offers on LinkedIn or any other job portal, and as they start observing MATLAB, Python, Scala, Apache, etc., they fear applying to the job because they believe that they need to fulfill all of the requirements. Was this your case?
Yes. I mean, this is something that I talk about a lot on Twitter, which is this imposter syndrome, which is this feeling that you are not good enough for the job. And I mean, you can have that feeling because of 2 reasons. Maybe it's because you are not prepared for the job. That's actually a subjective feeling that turns out to be correct. But there is a second, which is what I think happens often, which is people who are well prepared or who are able to learn fast, which is a key skill, who feel that they're not yet there. And this happens constantly. And this is what I said at the beginning. Reading job descriptions is like a good first approximation to the job. But if you can actually talk to people who are in those companies you're trying to apply, you should do it, because they will give you they will depict you the other side of the moon, let's say, and it's different. So in my case, yeah, I felt completely, I was hacking my way through the interview process, right? They were looking first for a data scientist. I never studied data science formally. I studied maths, I studied statistics, I hacked my way through programming, but I was not really a developer. So it was like everything was shaking. And there, where I read my job description was, you need to know Apache Hadoop, because the company at that time was using Hadoop on premises. You need to know Apache Spark, because this is what we're using to basically run our systems, our data pipelines. You need to know SQL. I never used SQL before. I was using CSV files, so why on earth I had to learn SQL? So Python was the language. I never studied Python. So basically, during that interview process, let's say that you find your way. I mean, I had some interviews before and I failed them, right? That was not my first. That was not like a happy path. But what I'm trying to say is that you will always feel you're never prepared for that job. Believe me.
Until you start.
Until you start the job, absolutely.
Yeah.
The good news is that people who are working and who are sitting interviewing you are aware that not even them are experts in the things that they're asking you to know. So this is when the human-to-human interaction is important. And if you are talking to someone who's not a robot, he or she will try to look not for what you know, but also for the things that you are close to learning, right? So one of the things that really matters in interviews, in my experience, is open questions. So basically, they present you a scenario, sometimes similar to what they need to solve, and they simply ask you to walk me through how would you approach this problem, right? So you start from, let's say, a very general level, and then you go top down, right? So you start first showing you understand the problem, and then how you start formalizing it and even solving it. But the key question is not how you solve it, right? It's not going to be, oh, you use an LSTM. Why didn't you use a transformer model for this? Because transformers are better, whatever. It never comes down to those details. It's more about how fast are you able to pick up my problem, my business problem. I'm a mobile gaming company. I'm trying to make money from people playing my games, and these are my problems. how can you, as a technical person, can help me solve that, right?
Yeah.
I don't care if you're an expert in transformers. Do I even need them?
Totally.
So
yeah, because for example, I see also people in my case as well, when I go into my first interviews, I felt the urgency to start answering to them all the time, you know. But then over time I realized, why shouldn't be me asking them on how to do the job, on gathering more information so that I can elaborate a better answer to them, right? Because don't you feel like people, when they go to job interviews, they feel an urgency to reply and say even things that they don't really know too much, just to fulfill the requirements?
yes, it actually happened to me a lot, because in Nordeus, after a while, after being, let's say, 2 years there, I also became an interviewer. So I was participating in the rounds of interviews for junior candidates. And this was a constant problem, right? Like, from what I want to get.
How many people did you interview in the?
It was not a lot. It was 5, 6 people.
But and did they all follow the same pattern when they had the interview with you, or?
It was similar, because most of them were recent graduates who wanted to enter. There was an internship program. But what I felt, there was this constant, let's say, excessive focus on trying to, at that time, LSTMs were the hot thing. So I remember asking questions like, we have that problem. And it was, I mean, it was a sequential problem, right? So I mean, most things in life are sequential. That's not very new, but it was how, based on past information about the user, how can you recommend the best thing to do, right? And the goal of that question was exactly to understand how he conceptualizes the whole thing. And then at the end, maybe comes down to a specific model, right? But the model in particular, that was not the question. But what happened most of the times is that we started, the answer started already with, I would use an LSTM. And then it's like, I mean, we haven't seen the data. You don't know how much data there is. I mean, and I understand there is an urgency to show that you know, right? And what you learn in most places are the tools, are the models. I get it. I mean, I'm not blaming anyone. It's just that.
Yeah, but
this
I
is
mean,
what.
the situation you are describing could help anyone that are new or want to get into a data science job, that they shouldn't behave in that way, because that mostly transmit unconfidence than confidence on how to elaborate the value through the data. Because, for example, if you go to a doctor and the doctor tells you to take ibuprofen, even though you haven't tell the symptoms, that's what normally happens, right? But yeah, I mean, so everyone should take some really good advice here, that you don't need to fulfill anything. Just talk with the interviewer, ask questions, don't believe that you know everything, or go with the best model, because in the data science field, it's all the time about curiosity. It's about making questions, not making a lot of assumptions. And in the end, you just generate the value through a discussion. But yeah. So moving on to the next topic, which other projects have you been involved rather than this one in Nordeus?
Mm-hmm. Well, in Nordeus, there was a cool project that I worked on. In that soccer game, there are avatars for players, right? So these are not real soccer players, but invented ones, because we didn't have licenses. So one of the things that I thought we could do was to train a model to generate realistic portraits of football players and use them, right? So instead of having 11 players in your squad with no faces, I thought it would make an impact, an emotional impact to players, to actually put a face to their players, right? And the thing was how to make this in a scalable way, because that game was played by 3-4 million people every day, each of them with 22 players. So you cannot hire artists to draw so many profiles, right? And at that time, that was in 2017, generative adversarial networks started gaining traction. So what people call GANs, were these, let's say, first generation generative models for images, where similarly to how things work now, basically they were able to sample from complex distributions, in this case, realistic images of people, right? So from a random vector, you're able to pass it through a network and generate an image, which really looks like a good approximation to a real image. Frankly speaking, GANs, I mean, what the community achieved in the last 6 months with all these stable diffusions is much more impressive, these models, that what GANs brought, but they were this first step. So I thought, why not? I want to prove that I'm a machine learning in this company. I'm going to do something that that people can actually see. And that was a very fun project. It didn't see the light. I mean, it was not green lighted. It was not really deployed in the product. But that was something that I really learned a lot. And I was really happy building. Something more down to earth that I was doing on a regular basis, even though you work in machine learning, you end up building dashboards. I mean, lots of companies, many job descriptions are about machine learning, but I mean, machine learning is great. It's very shiny, looks great on your resume, but analytics is what pays the bills. So in any company, you also do a fair amount of dashboarding. So I was building dashboards to basically understand how the product is doing, how the game is doing, and improve and make improvements. Because one of the things you realize when you work in data science is that you don't need machine learning most of the time, right? So if your goal is to improve a product, there are faster ways to improve it. So one of them being A/B tests. So basically you analyze the data, you see something that is a little bit off or something that is arbitrary. For example, certain configuration of the screen where users decide how much they want to buy. Well, someone designed it, but what about we iterate on the design? Because there are UI aspects which maybe they seem irrelevant, but they really change a lot how humans behave and how you actually monetize your product. And to do these things, you have A/B tests. You don't need to develop machine learning solutions to predict anything. So this was also some of the, let's say, most boring but impactful things that I was doing there. Right? There's usually a negative correlation between impactful and fancy. And yeah, A/B test is one of these
tools. Yeah, I mean, I see that what you said in the job descriptions, they ask a lot about SQL, dashboards, analytics, which is more doing the engineering part of the data so that the people in the business can analyze and take decisions to improve the product or follow a new trend on marketing, etc. Because it goes down to how can you generate value to the data with the data and then later organize the whole business better, right? Good. And later you went into TopTal after Gordius?
Yeah, 3 years after I started working, I felt I was not learning a lot. So I also wanted to change the way I was working. I was not really happy going to the office 9 to 5. And then through a colleague, I've heard of this freelance way of working. And then I realized that, I mean, I found out a few platforms out there, one of them being TopTal. And then I applied to join TopTal as a freelancer. And then I went through the interview process, the screening process, and I managed to enter. And then once there, I quitted my job. So I quitted. And then being inside TopTal, I started looking for jobs because one thing is to be in the platform. The other thing is to actually find
look for projects.
A project and find a client. And that was like 2-3 months searching. I mean, a little bit in between jobs, not trying to find my first project. And this is when I started working through TopTal. And the idea is that TopTal connects you with mostly American companies looking for developers, data scientists, machine learning experts. And then I started working in different projects.
How many projects did you do with TopTal? Were you involved at least?
I lost, I mean, maybe 10.
The count. 10.
Yeah, I mean, yeah, usually these freelance projects, they usually last 2-3 months. What they are looking for The typical situation is a startup. They got a round of funding and they want to develop something fast. So instead of hiring, instead of going through long hiring processes, what they do is they go through a platform, for example, TopTal, and they look for a specialist and they pay him or her per hour. So you're paid per hour to deliver something pretty fast. This is how it works. There are sometimes long-term clients who look for, let's say, full-time positions that last 6 months or more. But yeah, that's more that's less frequent. So it's quite dynamic, which is great. That was exactly what I was looking for, because one of the reasons I left my previous job was that when I'm reading papers, blogs, stuff, I see there are lots of new things in data science, in machine learning. But when it comes to my job, my day-to-day job, it's really the same again and again, right? So I'm losing a lot of opportunities to learn.
Yeah.
Like I want to learn more, and I have to do it after work. Why? I mean, why don't I convert my job into my way of learning also? So
yeah,
try to package everything.
Because that's a good thing that happens working in data, that it's a transversal field. You can apply to any other field in the world. So in the previous job that you had in Nordius, you were just all the time working with the football, the games data. And then when you move into TopTal, in which fields did you treat the data and develop the projects?
Well, the first client was a company called Zing. I don't know if they exist. It's a startup who were building self-driving cars. So they had a very small analytics stack. And my job, let me write it. No, it's actually a very confusing name.
You go. Zing, autonomous technology for industrial energy. Wow. So these cars around the industries, the factory, to catch up the packages. And which you had to do for them? Which feature?
It was not machine learning, right? Because one of the things that I realized when I applied for freelance positions is that, at least at the beginning, you need to apply for things you are already an expert in. And machine learning, I had done machine learning, I had developed, but I was not really a machine learning engineer, right? What these guys were looking for was someone who could build pretty dashboards, essentially. So they had tons of raw data, sensors coming from their vehicles, and they wanted to basically put them on dashboards so their engineers building the product understood what was going on, right? So my job was, together with the data engineer, extract data from a MongoDB, put it in a Redshift in Amazon, and then build Tableau dashboards and make it as fast as possible so that the experience for the engineers using the data was not a pain on the arse. So it was minimal infrastructure. It was about putting the numbers in front of the people. No machine learning at all. That was my first job. And that was...
For how long?
It was 6 to 8 months.
Wow.
But it was great in the sense that when you start freelancing, it's really important that you start doing something you already feel confident about, because even when you're confident about, the subject, it gets tough. So if you want to make your life easier, and if you actually want to land a job, you need to be a specialist in that. So at least at the beginning, even though I wanted to work on machine learning, I realized that I needed to adjust. So I cannot have everything I want right now. So I need to make a compromise.
Did you know how to make dashboards before getting to this job, or?
Yes, because this dashboarding was something I was constantly doing in gaming. So I was, Tableau became my best friend. So I was just tableauing my way up to freelance. And this is,
Yeah, and this is also a cool thing that, I mean, it happens in any other jobs, but not as much as in data science. You learn a skill in a particular job that you can recycle to any other job that it's on your career, right? And that feels pretty good because you are all the time in constant learning. And when you get the job, it's like you're doing even a master's inside the job, right? So
Yeah, that's one of the great things, that the tools and the ways of solving problems they transfer across industries and across problems. I mean, it's not a perfect, it doesn't transfer 100%, but there is a lot of technical knowledge that you can reuse.
yeah,
But I think one of the important things in data science, or at least in my experience, is this pivoting, right? So this is where you are right now, and this is where you want to be. And even though you want in your mind to put a straight line, as soon as you start working, you realize that there is no straight line. So you need to find, you need to find little compromises here and there. So in my case, I wanted to change two things at the same time. I wanted to go freelance, and I wanted to do only machine learning. And my starting point was, I'm a full-time employer in mobile gaming, and I'm doing data science and sometimes machine learning. And when I started looking for jobs in freelance, I realized that clients didn't buy it. Like, it's like, what have you done before? I mean, show me what you've built before. Why are you a specialist to build a system to forecast sales? Or, I mean, what's your experience with Amazon? Have you used this forecast service? And I mean,
but those projects, like working with Amazon Redshift, Tableau, etc., you learn those skills when you land in jobs, I believe, because, for example, to use the Amazon Web Services, you need to pay a fee, etc. So I don't know if, can you elaborate more on that? Like, people who are starting in machine learning will learn better to use the Amazon Web Services before getting a job or after getting a job?
After, because I mean, Amazon Web Services is a colossal, I mean, zoologic of services and stuff, right? So when you can learn individual services, right, you can follow their short tutorials that they put on their website. So you can spin up the infrastructure using a Terraform they put together, and you follow through the tutorial, and then you maybe use the client interface, the command line interface, and you get familiar with I mean, Lambda functions, step functions, and so on. But I mean, you're not going to be an expert, but the thing is, you don't need to be an expert to land a job, right? So if a company is using Amazon because they have all the infrastructure in Amazon, do your research, get familiar with the key technologies in Amazon. So learn the fundamentals of EC2, basically borrowing an EC2 to do your stuff, setting up a Lambda function, spinning up a DynamoDB, basically or even an API gateway. So get a little bit familiar with these concepts and maybe build something. I mean, all these cloud providers have this free tier, so you get certain amount of credit, so you can play for a limited amount of time for free. So I think that's a good opportunity for you to learn, but don't expect to be a specialist. I mean,
yeah. And yeah, some people are asking as well about using Azure, because in the beginning, you start learning Amazon Web Services, and then companies also ask to learn about Azure, the service from Microsoft, and you can feel a bit like exhausted because there are two separate things, and you believe that you need to learn those things separately. But are they the same? Do they follow some pattern? And this is align with what you said at the beginning, that universities should teach people on how to learn rather than just concepts separately, right? And there are patterns in these cloud providers between Amazon Web Services, Microsoft Azure, etc.
I mean, I'm no specialist in cloud services. I want to say that first. So I'm not a professional data engineer. You should follow on Twitter. But what I learned interacting with these services is that, yeah, there's an almost one-to-one mapping. So in every cloud service provider, being Amazon or Google Cloud, there's this concept of user, this concept of permissions, this concept of computing services, either on demand, either serverless. So in Google Cloud, it's called Cloud Functions. In Amazon, it's called Lambda Functions. So essentially, all these cloud providers are built using similar building blocks, right? The key technology being Docker, right? So in order to compute things, to run programs, you package them in Docker. Sometimes you put it in a Kubernetes cluster, if the company uses that, or if you put it in ECS, in Amazon, or you put it in Cloud Run, in Google Cloud, but I don't know the name in Azure, but the building blocks are essentially the same. Then apart from computing, there's storage, right? So there is, let's say, cheap storage and relatively slow, like Google Cloud Buckets or S3 in Amazon, or you have then more sophisticated kind of databases, like, I don't know, DynamoDB in Amazon is very popular. But what I'm trying to say is that the building blocks are the same, right? Then each of these providers is building, let's say, more complex or more abstract layers, like machine learning platforms. For example, in Amazon, this is SageMaker. Or now in Google, I think it's called Vertica AI. But these are like, let's say, more high-level wrappers around these services. So,
yeah. So the core functionalities here that you would recommend people to learn are Docker, SQL, I guess, to set up databases, right? And knowing these fundamentals, also like how they work, these services, what you said about the roles, the users, because you need to have the permissions to write in the databases, right?
yeah, I think if you've never had experience with, let's say, Amazon, the best way is you open an account, you create a root user, then you enter into the panel, and then the first thing you do is you create another user, which is the one you're going to actually use, which is not the root, because you don't want to use the root user for everything. So you got familiar with this concept of creating the user with the least permissions that can get you the job done. So with that user, then you go to your laptop and you install the Amazon client interface. And now you open one of their tutorials. For example, I don't know, setting up a Lambda function connected to a DynamoDB to do, I don't know, a service that returns a website, for example. So it doesn't need to be machine learning specific. It can be as simple as setting a database, setting a Lambda function, and serving something there. And these cloud providers have really good tutorials, and they're hands-on, right? So you follow step by step, and you set up permissions, you install the client interface for Amazon, you write some Python code for Lambda. So I think this is the best way to get there. It's not, at least this is what I do.
Yeah. And also, like when for example, when I started learning AWS, I thought I had to learn another language, but I saw that most of the functionalities are done with Python, so I didn't need to learn any other languages. So learning the basics of Python, you could get a hint on how these platforms work. For example, here, using the import request library, creating a function. So you go through these tutorials, and then you get a catch on how they are using the services. Good. So if you would have to recommend someone to get started on machine learning, data science, would you recommend them to do a master's, take courses online, do mentorships, hire a private tutor? Which one would be your take at the beginning?
Well, as I said, I don't know what's the format you need. I mean, I don't know if the best is a master, because I don't want to be unfair. Not all masters are the same, like not all mentors are the same, right? It's not black or white. In my experience, I didn't take a master's in data science, so I cannot talk based on my personal experience. I can only say what I got talking to people who went through programs. Some of them being people they're in my mentorship program. One of the things that I realized is that, as it happens often in academics, there are things that are a little bit detached from reality. So if your master program is not really connected with real world problems, with industries, with real problems, what happens sometimes is that you study things that you will never, ever use again. In my case, for example, something that I find a little bit surprising is that in a lot of master programs, people are still studying R plus Python, which for me doesn't make much sense, right? It's not about Python. Like, as I said before, Python in 10 years is not going to be there, but it's neither about learning Python and R. That doesn't make any sense, right? It's like, the idea here is that you understand how to articulate your thoughts in computer code, right? So it's not about, I see basically you're wasting time there. And my impression is that master programs, they need to last enough, right? A master program doesn't last 2 months. it needs to last enough. So let's put content so that we get a program that looks good. And what I suspect is that many times you end up studying lots of stuff that are there without any purpose, right? And as I said at the beginning, you need to look at what do you want to end up working on, right? You need purpose, because, I mean, the purpose of master, yeah, because the purpose of master programs is that you pay the fee and you stay happy with them for 2 years, and that's it, right? And if you don't set purpose for your life, someone else will put it, right? So,
yeah. And
so
have you had experiences with people that felt that the masters was a waste of time in particular cases?
No, not I mean, not a,
like not in the sense of a complete waste of time, but that the advantage at the value that they got from the masters compared to, I don't know, learning from YouTube tutorials or going more on their own pace was better, or maybe that they should have reverted the equation in a sense that first they start with tutorials online, and then once they know what they want to go, then they start taking some masters more consciously. Because I don't know about you, but I feel that we get attracted by the fancy name of the masters, like artificial intelligence applied to sports, and we see, whoa, I'm gonna be doing things with images, the players, the football, Messi, Cristiano, and then you get inside the masters, and it doesn't provide you the tools and the value that you expected. And maybe if you would have started the other way around, you could have taken a more conscious decision on which masters would you like to take, right?
yes, because I think masters play on the game, play on this thing that you're gonna get a certificate from us, and this has value. But what I realize is that employers, companies, honestly, they do not care how many certificates you have. When you're looking for a job, having a certificate is good, but there are other things that are really what make or break the deal. And these are mostly, what have you built? Show me something you've done, right? Don't show me a list of certificates, because, I mean, it's also the business of education, right? I mean, producing certificates is a business. And what happens is that certificate is a signal that you know, but I don't know how strong of a signal, right? So this is why I said at the beginning, not all masters are the same. I don't want to say that it's a waste of time, no. But when you choose your program, really ask not what are the subjects you're covering, but how is this connected to real work, right? Are you connected with companies? Are we going to work on projects? Are we going to get real data sets to work on, right? Because my experience talking to people with masters is that basically they think they learn, but it was too slow. And I get it, because in the masters, I mean, most people, including myself, I don't feel comfortable going through YouTube and start learning from scratch. At least when I started learning, I felt this is too chaotic. I need some kind of direction, and a master gives you this direction. But the thing is that in this initial phase, you learn a lot, and they actually give you structure, but then it becomes like a real clear, clear plateau. Like it stands too long, this plateau, and then at the end of the masters, you build the project, right? And when I realized that, well, I needed the beginning and the end of this program, but there's a lot in between that I don't really need it. And this is something that I think when you work with a mentor, it gets, let's say, more honest. Because, I mean, as a mentor, I'm not here to entertain you, right? I don't want to have you around for 2 years, then doing this and doing that. No, I want you to find a job, right? I'm not giving certificates. I don't want you to pay, so I give you the certificate in 2 years. I want you to be happy because you found a job, and then you're going to recommend my services to others. So in this respect, it's much more honest, right? I don't have like an aura or a magic name that I'm saying, I'm going to put my name on your CV. No, I'm gonna be result oriented. And to be result oriented, I'm going to help you build stuff and get a job, right? So this is,
because what you said about showing off what you do while you are learning Python because companies demand you to show off the skills that you have been acquiring. What do you recommend people to do to show off their skills?
I mean, in technical interviews, when you ask the candidate how do you implement a linear regression using basic methods, this is something that people get nervous about, but I think it's revealing, because what I recommend is that basically you understand what you're doing, right? Because I know that the linear regression is just one line in scikit-learn, right? So you split the data, you call linear model or whatever, lasso, whatever, you fit, and then you transform, and that's it. But sometimes what they're interested about is not if you know SQLearn API, right? Because that's something you can Google, but do you really understand a little bit how it works inside? Because, I mean, depending on the job, you really need to go deeper, right? You need to understand how the model works, because this is the only way to find a better model. So being able to do simple stuff in Python with clean code, with fundamentals, it's also something you can practice, and something that will give you a lot of clarity. So you can do it once, but do it at least once, right? I agree. Later in the job, you're not going to start implementing things from scratch. But if you know them how to implement from scratch, basically, this is not about what you learn, but it's this meta learning, right? You're going to be able to decompose more complex things into the fundamentals and learn it. Because what happens nowadays is that there's a lot of cutting edge research, and then they make a library, and then the library abstracts away everything that happens inside. So you as a user have the impression that, okay, I'm just going to use this model and fine tune it, and that's it. And what happens is that, well, if it works, perfect. But if it doesn't work, you don't have a clue what's going on, right? So being able to decompose this thing into the fundamental steps can actually tell you where you might have the problem, right? So that let's say modular way of building is something that it's a long-lasting skill, and this is something that if you get used to from the beginning, it's going to help you.
Yeah, and also like people who do masters, take courses online, if they want to show their practical cases as a portfolio, what do you normally recommend? Like to put a website or?
I mean, something that I do with my program, with this mentorship, is first you build it on public. So you put it on GitHub and you make the repo public. You put a nice read.
Your user was in the GitHub?
It's called Paulescu, but my mentees projects are on their GitHub account. So, I mean, let me find one. Let me copy this link. Let's say, it's public. Yeah, sorry. This is, some of them are public, some of them are MBA. So for example, yeah, this is public. I'm gonna take it. So this is a project that I'm working with Charles.
You need to paste it into the chat so that I can paste it here. Otherwise, it won't.
Let me.
Okay, good.
So, for example, Charles is he's a physicist. He's not happy where he's working now. He's doing some kind of lab stuff, and he wants to get into machine learning. So I said, let's build something. And he's interested in the MBA. So what we're building here is a model and a real-time system that will fetch data about matches, upcoming matches, and historical data, and will shoot probabilities. So every day, if tomorrow there's going to be a match between, let's say, Los Angeles Lakers and Portland, the model will output a probability saying the chances of each team winning, right? And the good thing of this is that it's a project that you can see the code, it's there, but also there's going to be actually a system working. So for example, you can, for every repo that you have in GitHub, you can add a GitHub page. So it's very easy in GitHub to actually have a visual interface for your work, attaching a website to it. So the idea is simple. Let's fetch data with let's call it a data pipeline that runs every day. Let's check what are the upcoming matches, and then let's score each of them, and then let's generate probabilities. And these probabilities, I mean, the project, maybe he makes money betting, I'm not sure about that because betting houses are bad
Well,
guys. Yeah. But at the end of the day, he will have a website. He can actually share the URL and say, look, it's a system working. So yesterday it predicted that chances, and I mean, take it or leave it, but it's actually working. So
normally, how
this is
long
one
does
example.
does it take to develop a project like this?
Around 2 months.
2 months.
Yeah. So
See. Do people need to have some previous knowledge about Python?
yes, I recommend to have not to be a complete newbie, right? So if you've never trained a machine learning model, do it first and then apply, because the idea of this program is to work on weekly sprints, right? We set the final goal and we work towards that goal on a weekly basis, but it moves fast. So I don't expect people to be experts. No, I want to help people get into the science, but we don't really start from the fundamentals. You can start, but then you will need to put a lot of extra work. So as anything in life, it takes time to assimilate. So let's first cover the fundamentals. So let's do on your own, at your own pace, take a toy data set, fit a model, then go to Kaggle, try to copy solution. And then when you feel a little bit comfortable, then we can build something, because this is very focus oriented. We decide on something we're going to build and I help you build it. It's going to be a lot of exploration. It's going to be like the most straightforward path towards that final product. So in this case, for example, Charles, he has experience with Python, but every week there are things that he does great, but there are the things that, okay, let's, for example, in this case, there are things that he's tracking in the folder that I told him, well, you shouldn't put on your repo, for example, this Neptune dashboard. So we use Neptune AI to track experiments. So this folder is something that you can put there. There is something in the feature engineering pipeline that I think it's wrong. So basically, on the way, he's building it, but I'm, let's say, keeping him
you
on
help
the right
him
direction.
To be efficient on the approach and not and save time to face the errors, because when you are going on your own, I believe that we get lost and we may take 1 month to learn one thing that if we would have been guided, we would have learned it in, I don't know, 1 week or hours sometimes. So good. So people who would like to join your program, how should they look for you?
Well, through my website, which is datamachines.xyz and /mentorship. So yeah, this is the main page where I share the details, basically how the program works, how much it lasts, which I said around 1-2 months. I mean, 1 is if we are very fast, but in my experience, it's more 2 than 1, and also the price. And there you can apply. And to apply, I ask you to answer a few questions to understand where you are now and where do you want to go. And then I contact you from that point. So it's quite simple.
Good. So for anyone who would like to give it a try, because I think here you have a 7-day free trial in your program, give it a try and get help from someone who has been already working in the field and who can drive your learning path to get what you want faster. So Pau is your guy. Now we go to some questions from the participants. I don't know if you want to talk, Maria, Aria, Adele. Some questions who were here are masters more theoretical or versus no hands-on projects?
As I said before, I didn't participate in a master program, so I'm probably not the best to answer that. I would skip that because I don't wanna lie.
I could okay. I could say something here because many of my clients go into master's programs. They are hands-on. I mean, they send, depending on the program, you should look for again asking the people in the university that's offering the masters if they are doing many practical exercises, how you do it. The bad thing I would say is that as there is one teacher for many students, you face the risk that is the class is increasing their level, you risk getting lost and not catching up with the rest. So at the end, you may feel like you don't have the time to learn all at the same path, and you could avoid this type of thing by having direct guidance one-to-one. 1 second. I don't know if Maria, that answers your question. You could ask something if you want. And there is another question. Jesus, please share the link of this page. There is it in the chat. Now, another question is, which machine learning model is good? What should be the parameters that we should look into, like accuracy, score, MSS? Yeah, this is more aligned with about what you said before, that it's not as much as important to know how the models work, because you can learn this in Google, Stack Overflow, etc. It's more about giving value through the data. How do you develop the whole context? How do you understand the problem that the company faces, or that the data that you are working with, and then later you develop a solution, which you can use even techniques that are not related to machine learning, right, Pau?
Yeah, I mean, first you need to define if machine learning is what you need. And sometimes it is. And if that's the case, now what's the best ML model? I mean, there is no absolute winner, right? Depending on the data set, there are things that a priori should work better than others. For example, if you're working on computer vision problems, I mean, neural networks are, I mean, there are classic techniques using OpenCV that you can use to do basic image processing. If you need something more complex, convolutions and neural networks is what you need, right? But in most cases, most enterprise data out there are not images. Most enterprise data are tables, tabular data. So you have rows and tables, right? And to do machine learning in those kinds of data sets, there are a lot of models you can choose from. In my experience, a well-tuned boosting tree solves 99% of the problems. So if you have enough data, if you have, let's say, at least 1,000 observations, let's say as a rule of thumb, this is not something, but if you start having 1,000 plus 10,000, if you feed something like XGBoost or LightGBM or CatBoost, you should squeeze a lot of signal from that data. Then later on, you can start fine-tuning the hyperparameters. But this will only add you, I would say, marginal increments, right? So the question, what ML model is good? It depends on the data. A priori, what is good? Tabular data, boosting trees.
Good to know. So Adele, I hope that the answer serves you. If not, then let us know. Good. Then later, what if the projects are confidential for a specific client? How can showcase it? You can't, right?
Yeah. This is a very good question because it actually happened to me, and I learned never do it again. So sometimes a client comes to you and says, we're building something super confidential. That project, you're going to sign on this contract under which you cannot talk about this at all. Yeah, it's a pain on the arse, honestly, because one of the things of building projects is not just earning money now and doing it, but being able to share it with the world after. So my first advice, try to fight that. So if they want to actually force you not to talk, try to get on terms of saying, I mean, I don't want to publicize what we did, but I would like to be able to at least, of course, not going to put it out there. I'm not going to share the code, but at least I can add it in my LinkedIn profile. I can add it somehow in a way that it shows that I know what I'm talking about. So yeah, this is something that I learned by doing the mistake of accepting those projects and then realizing that it's like as if I've never have done them because I cannot talk about them, and that's really it's not, you're not investing in yourself, right? So you're just earning money today, but not investing in your portfolio. And yeah, I would advise you to avoid that.
Good to know.
Or the only or is if they pay you real good money, obviously. So if someone is willing to keep that confidential, you should negotiate it on the money side. So if you don't win exposure, at least pay me an extra. So this is what I learned by doing the mistakes.
So anyone here listening could learn from this mistake. Arya, you have a question, right?
Yes, can I unmute myself?
Yeah,
I
sure.
just did.
Go.
Yeah.
Yeah,
Yeah,
yeah.
hello.
I mean,
Hello
we'd,
again.
we'd love to hear more people than just us, right, Pau?
Yeah, so my question is to Pau, like what projects did you work on previously, and what technologies did you use, and what technologies or libraries should I use while working on my project? Could you walk us through like few of your initial products when you started out?
You're asking about technologies that I used in data science and machine learning.
Yeah, those as well.
And if
I
you
mean,
were to start, what would you advise some people to learn? Which libraries, tools right now, the ones who are starting?
well, the first thing is Python, because it's not about building stuff with Python. It's not about using machine learning libraries or scientific packages, but it's also the language, the most common language to interact with cloud services. So as Jesus said before, Amazon, if you want to develop a solution in the cloud, it has a very nice Python API. So the way to set up the services, to call the service, so you want to put data from your EC2 instance to a database, you use a Python command. So Python is not just, it's like a glue, right? It's not a very powerful language. It's not C++, but it has become the standard language to glue together everything, right? So one of the things that you need to know is Python, right? It's not about mastering. You need to get confident enough to develop stuff. You're going to master over time, right? So Python is one of these. And the other thing that I would recommend, because I think it really gives an edge right now, is learning enough cloud services so that you can deploy and showcase your stuff, right? Sometimes you don't need to go through Amazon and become an expert in several services. Sometimes it's enough to know about GitHub Actions, about some third-party providers that set up a database where you can put your features, and then a system to retrain your model. And with these three elements, you can have a prototype which is public and which you can showcase, right? Later on, you can also make it using cloud services. So you can use, let's say, step functions to schedule things. You can use Lambda to deploy your model. So you can map it to a more, let's say, professional stuff. But knowing Python and knowing how to connect the pieces, I think these are two things that really make a difference nowadays, because I have the impression that training models has become very standard, right? And in 10 years, I don't think machine learning engineers or data scientists will be training models as they're doing right now. I think it's going to be more about connecting things and building stuff. So these are two things that, I mean, I'm learning myself. I'm not an expert in cloud services. So, but if I had to start, I would like to have them in the mix from the beginning. So don't stay only inside Jupyter notebooks, but try to see a little bit beyond them, because again, you don't need to be an expert, but at least be aware of the pieces.
Good take.
Yeah, actually I have a question. Yeah, so maybe it depends upon the role, because there are many roles in data science. Data science fields, you could be a data scientist or a machine learning engineer. For that, you require different set of skills. As you said, cloud. If you're a machine learning engineer, maybe you'll emphasize more on the cloud side. But if you're a data scientist or a data manager, you might shift towards the theory or the visualization part. Or if you're in the analytics, you'll have to focus more on the analytics. So when you're starting out, how do you decide, and how do you choose, or do you have this liberty to choose or not?
Oh, well, I think you need to choose always what interests you the most, right? One of the things that it's really attracting people in these fields are the salaries, right? So I constantly see those posts in LinkedIn saying, how much does a data analyst make a year? How much does a machine learning? And I think that's the wrong approach. You should work on the things that interest you, right? And at the beginning, if you don't know, then just try, right? What I think makes more sense to try at the beginning is to what is closer to what you know right now. So I think it's important, this concept of pivoting. Right now, it doesn't matter what you studied, you have some skills. This is where you want to go. As I said before, very rarely you go with a straight line. Try to find the things that are closer to what you did, that you like, and you can somehow transition there and try it. Because in my case, I started building dashboards and I was enjoying it for 2 years. And then at some point, I find it boring. But this will happen, I think, with any field. Like I like learning new stuff. So this is when you see machine learning and then, okay, let's try machine learning. But your driving force should be, what are you interested in? So whatever you're working on, do your job, but always keep an eye on what's going on and try new things here and there. Like it's like this exploitation, exploration balance, right? So you need to efficiently search in the space, you need to combine both things. And this should be your let's say your driving force. But forget about salaries, forget about things. Honestly, all these jobs are really well paid, right? Being in data science, being in all these things, it's a big lack, right? So it shouldn't be maximizing your salary, because if you are good at any of those fields, you're going to be well paid.
Good. Thanks for all of this knowledge. Just the last question here from Adele. I don't know if I am pronouncing well the name. Or
Yeah, you're pronouncing the name well. Thank you so much for giving the time. Actually, I want to ask is, I'm already, I'm really confused about the term that belongs to data normalization. When should we do that and when should we not do that?
Data normalization.
Data normalization in machine learning.
Okay.
Do
you mean in the terms of scaling the data, or do you mean in terms of, for example, you are comparing,
like reshaping the data in a specific range?
Okay. Depends on the problem that you're working on. Could you elaborate an example, please?
Okay. Let's say we have 4 or 3 attributes. One attribute contains the values like 0 and in between 0 and 1, and one contains the values in around like 1 million and till 10 millions. So should we normalize it before passing it to machine learning, or we can pass it directly to machine learning model?
Well, if you have variables with different scales.
Yes, exactly.
Okay. Depends on what you want to do, but I can respond to this one. For example, machine learning is all about a mathematical equation, right?
Yep.
If you have a neural network, you have many coefficients, right?
Mm-hmm.
So if you pass to the model features which are in different scales,
mm-hmm.
some coefficients will be very high and some others will be very short, you know?
Yep.
So when you are optimizing the model, some coefficients may get very 0,00000 in a way that it's harder for the machine to optimize it. I don't know if I am wrong here, Pau. What would you say?
No, you're right. For certain models, like linear models or neural networks, which are basically stacking linear models with non-linear activations, there is this numeric problem, which is if variables are in different ranges, it can happen that the model is basically the optimizer gets lost. This is more like a technical problem. It's part of mathematical optimization, right? And when you have these big imbalances, magnitudes of the coefficients, the optimization problem behind gets harder, but it gets harder unnecessarily. You can fix it by normalizing data. The thing is that this normalization step is necessary if you use linear models like Lasso, or you use neural networks, right? But if you use, for example, boosting trees, like tree-based methods, are not sensitive to scaling because they work differently. They don't work with terms of coefficients or optimization, but they take a feature, it doesn't matter if it's scaled form or it's in raw form, and they try to find smart partitions of that feature and of the other feature. So, for example, if you use an XGBoost model, you don't need to normalize inputs in this way. You don't need to subtract the mean and scale by the variance. you can do it. Maybe it helps a bit, maybe, but this is not. If you don't scale when you, for example, build a neural network, if you're a neural network, you send raw pixels, which are numbers from 0 to 255, it's going to break if you train it with those, most probably. So yeah, this normalization is what Jesus said, is a way to help the optimizer work. But it's not always necessary. It depends on the model.
Okay, that makes sense.
Good.
I have one more question.
Okay.
Okay,
About-
that is related to the freelancing platform. So if, let's say, if someone has rejected from TopTel, then what other option we have? Because I'm
Well-
already using the Fiverr and it sucks now.
Yeah.
So
You could use, I mean, there are many others. What I find most interesting is private tutoring, maybe. There are many websites like Code Mentor, Superprof in the in the US, Ysant. So I would try to apply for those and just show off your skills. You could get some freelancing jobs. But if you want to get into machine learning projects, I think you need to overcome these platforms like Upwork, TopTal, the Fiverr, but they normally they are not as professional as TopTal, I would say. But you can
Okay.
keep trying.
Okay,
Or maybe
one more.
you can find a job in which you are developing models and getting more experience on projects, and then later apply to TopTal, I guess.
I see. Is it a good idea that we can get a job from social media? Like if we advertise our skills on the social media, and then can we get hired from that?
What would you say, Pau? If you
Uh,
advertise on social media, can you get the
Mm.
jobs from that?
Like a
Yes,
freelancing job?
yes, but I think you shouldn't follow what I think most people do, which is they say, I'm open to work on LinkedIn, and then they wait. Because I think you need to explicitly say, what are you open to work on? So what are you offering? What have you built? So I think it works. It happened to me. Like I mean, I didn't get the job, but I was contacted to start doing things directly from social media. But I think it's important that you put the time to really show what you can offer. So maybe you need to open a GitHub page or put a profile. Like, for example, I'm going to type, there's a service that I can share here. It's called card.co.
You
So
click.
basically,
Can
yeah, let me click it
you
there.
show me?
This one, yeah. So basically, there are services that can help you build and publish a landing page where you put your portfolio in one afternoon, and it costs, I think, it has a free plan. Or if you want to get more features, it costs like $19 a year. So basically, there's a very fast way to put a portfolio. So yeah, put it on social media, you're open to work, but then put a direct link to what you offer, because I mean, that's at least my impression. When I see people open to work and that's it, I said, okay, I'm also open to work. I mean, everyone is open to work, but what are you really offering me?
Yeah.
And if I click, it's easier to find, and I see that what you're doing makes sense to me, then I might contact you. So yes,
Good.
I see.
it
Well,
works.
thanks
Okay,
a lot
perfect.
for all of the questions, the interactivity. I think that this space can help anyone who wants to get into data science to get a good direction from someone who has been in the field for how many years in total? Pau?
I mean, working with numbers, 10 years, no? But it was not called data science back then. So
At the time.
less, 7.
But yeah, I hope that you get value from this space and you learn from someone who has been on the field working in data science hard time for 7 years. That can save you a lot of time. And if you need some assistance to help to have someone helping you on your path, you have the mentorship with Pau, which is great. You will build hands-on projects. You can reach out to him in his website or Twitter if you want to have more information. And I hope that this has been a good space for the people here interacting with us. And for next time, we'll have another guest. So I will see you in the other. Bye bye, everyone.
Bye bye.